voltage, if you have the voltmeter and you measure the voltage face to face for three-phase systems, you're going to see, let's say, 480 volts. So that's the actual voltage, what you're going to measure using the voltmeter. So on the nameplate, you see the rated voltage, but the operating voltage can be technically anything below the rated voltage. But in the US, the three-phase voltages, the three-phase low voltages are 480. What else?
277
277 is phase to
ground.
phase to ground. So 480 slash 277. Phase to phase, phase to ground.
240,
We have
120.
120, 208. 208 is going to be face to face, 120 is face to ground. So 208 is the operating voltage, 480 is the operating voltage. But again, if you look at the nameplate rating, you see either 600 or 1000. So that's the difference between rated voltage and operating voltage. All right. Mario had a question. Yes, I didn't answer his question and he got upset and pissed about it. All right. Power factor. Power factor. I'm supposed to finish up. We have 25 more slides and let's see. Perfect insulation, 0% power factor. Why? Let's jump into this diagram. So here I want to introduce a couple of terminologies. You have the leakage current is here. Okay, this is the dielectric Watts losses or leakage current, IR, and that's what we measure using MEG, the leakage current. The vertical axis is your capacitance current. And you have a vector diagram, so this is the vector summation of the two, and I sub t is the total current. Now, the power factor is gonna be the cosine of this angle.
On the top, double band company gonna show up. Yeah, and then meter.
IR, leakage current,
Gotcha.
IC, charging current, or capacitance current, or charging current. And then, if you add up these two together, you're gonna end up getting something like this, and this is I sub t, the total current. This one is gonna be phi or beta, and cosine of theta is gonna be, some reference books call it theta, some of them phi, but it's gonna be your power factor. In a perfect world, I do not have any leakage current. If my insulation is perfect, no electron is passing through the insulation. So my leakage current is gonna be 0. If my leakage current is 0, if my IR is 0, then my total current is gonna be the same as my charging current. And this is gonna be a 90-degree angle. What's the cosine of 90 degree? 0. 0. That's why for perfect insulation, the power factor is 0. In reality, we always have some leakage current. That's why your power factor is not zero realistically. It's for the insulation, your power factor is always, a small amount. The other item I wanna mention here, getting back to here, this angle, I'm gonna call it delta. This is a small delta annotation. Tangent of this angle, tangent of delta, we call it dissipation factor. So again, in real world, if the leakage current is zero and I have a perfect insulation and my total current is the same as charging current, this angle is going to be zero. So my delta is zero. What's tangent of zero? Tangent of zero is tangent of zero is zero. So dissipation factor will be also zero. So if I have a perfect insulation, the power factor for that insulation is going to be zero cosine of theta, and dissipation factor, which is tangent of delta, will be also zero. But realistically, we know that's not the case. So technically, power factor and dissipation factor is the same thing. When you go out in the field, sometimes they call it a power factor testing, as what we have on the screen, and sometimes they call it tan delta testing. For example, for cable, you can perform non-destructive tan delta tests.
Delta and theta are referring to the same angle?
No.
Or
Let me get it back
confused.
to a realistic scenario. That's my total current. This one is delta, and this one is theta. So, power factor testing and tan delta testing, or this dissipation factor. Tan delta is dissipation factor. Power factor or tan delta is the same concept. Tan delta is newer kind of technology testing. It's being used mostly on high frequency systems because that gives you more accurate test results. But at 60 Hertz, power factor or tan delta, both. So if you hear a tan delta test, the concept is similar to power factor. The brain of the system is measuring the same thing. It's measuring the charging current and it's measuring the leakage current of the insulation. And then it does the internal calculation, and at the end it's going to give you the dissipation factor or power factor. That's going to be the output of the test instrument. So this is power factor. Let's move on to the next slides. Dissipation factor and power factor. Dissipation factor, we said it's tan delta, and power factor are essentially equal. If you have a good insulation, 0 to 10% power factor. Again, this is the power factor for the insulation. Okay. These are all insulation testing. We are checking the integrity of the insulation. The other factor which is impacting the insulation test results, just like Megger, is temperature and humidity. So everything should be corrected to The temperature should be corrected to 20 degrees Celsius, which is 20 degrees is 68 degrees Fahrenheit. So everything should be corrected. If you are testing an equipment in extreme weather situation, it's very humid or it's very cold or it's very hot, then you have to take that into consideration. This is from IEEE standard that it should be repeated at or near 20 degrees Celsius, or it should be corrected based on the tables we have. So these are the correction factors that you're gonna be applying. We have similar tables for measure. So again, in extreme temperature or humidity, you have to take that into consideration when you wanna write the report and interpret the results. Let's see what else has left. Power factor testing can detect moisture contamination, deterioration, surface contamination, and we said, leakage current is gonna be through it's gonna be arcing, but surface leakage current is gonna be through dust and dirt. So if your equipment is dirty, it's gonna impact the results. If it's humid, if it's foggy, it's gonna impact the results because water is conductive, and you may have some impurities, contamination, or particles within the insulating gas, what you have inside the bushings of the breaker or inside the tank of the gas breaker or oil breaker. So it's gonna detect everything. The modes of operation, the modes of testing, they are divided in 3 categories. You have GST, grounded specimen test, GST guard mode. Here you have the test equipment guarded, and UST is ungrounded specimen test. So you're going to be getting 9 results, 3 modes for 3 phases. This is the test setup. It's kind of portable. It's about, let's say about 70 pounds. It's not that heavy, 60, 70 pounds. You have a lot of leads, so you're gonna connect it, and this one is the ground lead. Ground always goes on the test instrument first. Ground is gonna be made first, and it's gonna be broken last. Yeah. First to make, last to break. This is the hook attached to the instrument. So this is what you see. The hook in this scenario is going to be attached to B phase, and then the other leads you're going to connect it. You have blue leads, red lead, and the test instrument internally is going to be doing the calculation. This is the GST. This is the GST ground test mode. So here your equipment is grounded. Here is UST ungrounded. So you see here is grounded, here is not grounded, and here it is guarded. For the guard, it measures total current to ground. It measures current through the red or blue leads are ignored. So it's kind of measuring that surface leakage current, similar concept to measure. UST, ungrounded test mode, measures insulation between 2 ungrounded terminals. And the GST, it measures both leakage path, which is the surface leakage current, and also through the insulation. And these are the diagrams for air circuit breaker. medium voltage. Again, power factor is not used for the low voltage. And that's gonna be the test results. So you're gonna get 9 tests. These are the USC ungrounded mode, and these are for grounded and guarded modes. You have 2 results A phase, 2 results B phase, and 2 results C phase. The total is gonna be 9. Numbers. You hook up the leads, you run the test. Are these numbers good or not good? Look at the manufacturer literatures and publications. If you cannot find it, compare it with the sister units, or look at the previous test data. Look at the trend. It's getting worse. You have to flag it. But there is no rule of thumb here. For example, for GE Magneblast, this is one type of General Electric medium voltage breakers. We know up to 5% power factor is okay. If it's 10% or higher power factor on the installation, do not energize it. It's a big no. So there is no specific number. There is no one number fits all sizes and types of breakers. So these are more kind of a specific type of test. If you are in trouble, just contact the Doble. If your test instrument is Doble, contact their customer service, technical support. They're gonna help you out. These are for vacuum breakers, similar to air breaker. These are the example test results, and you see the test voltage is 10 kV. These are milliamps. Even in milliamps, you're gonna see 0.2. So we are looking at 254 microamps. So very small leakage current, and these are the watt losses on the insulation. That's it. Mario.
I ask you, so the company that's coming at the top, those are the leader.
It's Doble. Doble is not a leader company. They manufacture test instruments.
Okay, and then are they gonna be coming, just talk to us, or is it gonna be kind of like resellers? Just gonna get in applications and stuff like that?
No, they're gonna be here mostly to show you the test instrument. We're gonna have Doble van. They're gonna bring in a van and they're gonna show it to you. They have all the common instruments available. Perhaps they're gonna focus on, I don't know. Sometimes they talk about cables, sometimes they talk about breakers. I don't know what they're gonna be talking about this time, but they're
Just
gonna talk
educating.
about testing, perhaps for an hour, and for an hour they're gonna take you out and look at the van, or they're gonna do the testing. You know, each time is a little bit different.
And then the one on the 19th, that's gonna be.
19th is from NIDA, so NIDA reps. 2 NIDA reps are gonna come here and motivate you about NIDA work, and why you should stay with this trade.
This guy's taking all the job, right?
But
Gonna be if anyone, that's not one to us.
yeah, because he's applying, so that's good. I mean, you have to apply until you find the job, you know. I met a new guy. He's a really nice guy, knowledgeable, fresh out of college, and he's doing internship with Socalis. So he has the college degree, educated, young, talented, and I asked him, well, was it your first application? And he told me he applied for, guess how many companies? He applied for 100 companies, and out of those 100, he got 3 offers. You know, you don't wanna pay too much, fresh out of college, young, talented, everything looks good. And
Better than it was 3 years ago.
out of 100, just 3? I was surprised, so.
For fun.
I know, these days it's not easy, and believe me, when I hear the old stories from the old guys, well, they were working in a company, they were making a decent money, and your friend was working in Port of LA or Harbor, and, you know, they called their cousins or neighbors, hey, we have an opening, do you wanna just come and work with me? I mean, that was the way it was working, right? But nowadays, it's harder because everyone is asking for certification, some sort of
Experience.
college degree, experience, yeah, but our vision in this class is that you guys don't have any high voltage experience. You know, some of you may have low voltage or medium voltage, residential, commercial, but the thought process for this program is, okay, we're gonna have some talented, interested folks who don't have the industrial experience. And we are trying to introduce you the basics. You're gonna do the hard job out there when you get hired by NIDA company. Yes, sir.
I want to add 2 things. Point 1, I've been reading that we're in the worst job market in over a generation. So that's, consider that. It's not always bad, it's just really bad right now. And then number 2, when I was fresh out of my bachelor's degree, when I got my automation degree in 2022, I didn't look for a job till 2023. I had other stuff happening. I couldn't look for a job yet. But when I started to look for a job in 2023, I applied to, I think, at least 1,500 companies on LinkedIn and Glass.
Wow.
1,500. Guess how many interviews I had? I had 7.
Wow.
Guess out of those 7, guess how many offers I had? 3.
Wow.
I had 3 jobs out of 1,500 or 2. I was applying like 6 to 8 hours a day for like 6 weeks, just all day, upload, submit. And I think it just gets lost in the.
Yeah.
I think it just gets lost to the AI Ethernet atmosphere. Like it just
Well,
gets
the
lost.
job
In,
market is shifting. It's changing.
you put an F there. It's shit, not shifting. No, it's shifting.
But it depends. I mean,
But to add, you know what? That was in the beginning when I was out of school with no experience.
It's more competitive.
I didn't.
I agree.
I didn't have what do you call it? Externship or what do you call it? Internship. They didn't have it because all this stuff for my degree was shut down because of the pandemic. They wouldn't let us in factories.
Yeah.
So I got the degree with no experience. So it gets better when once you have a little experience, or any relevant experience connected, somewhat connected, you're all right. But if you have like 0 experience, you got to build it up, because companies they don't want to train you. That's the problem. They say, hey, do you got any experience? You say, oh, I got some in lab. And they go, so do you know this? Do you know that? If you start saying no 2, 3, 4 times, your interview's not going to go further. Usually you don't get a second interview because they go, do you know what VFDs are? Yeah. Okay, how do you control it? You don't know? Okay, you know PLC? Do you have any coding experience? Yeah? Oh, no, you don't? Okay, cool. Well, thanks for your time. We'll let you know.
Yeah,
And you
it's
just-
more competitive.
you just
Now,
get-
believe me, if you think 10 years from now it's gonna get better,
Yeah.
you're wrong.
It's going to get harder.
All
Yeah.
right, so I'm looking at the quiz. When you take the quiz, make sure you are paying attention to the units. Okay. For example, here for the open test and closed test, you see the times in milliseconds and seconds. So pay attention what we are asking. Okay, I try to highlight it, make sure. If you read it carefully, you're gonna know which number to use. Now, about any questions before we move on? Okay. Now, tonight
Oh,
we're
yeah,
gonna
no?
be working. Yes, sir.
I'll get it.
Thank
you. Was that the homework for the lab?
For their schematic.
For the circuit breaker, usually they use very different symbols.
Okay.
Oh,
But was it in a way that you understood what
Yeah.
it means?
It is
Okay.
slightly different, like for their circuit breakers, the for
No,
I still
oh,
remember.
yeah, okay, okay.
Then having,
Thank you.
you know, if you put two zeros and then you put the U,
Uh-huh.
they actually had
Oh,
a
sweet.
circle. Two circles and one circle.
Okay. I mean,
And then
at
for
least
their
you
switch-
understood what it means, right?
Yeah.
That's the good part.
Thank you.
We're gonna be working on the control circuit of the circuit breaker. You did the Megger and DLRO on this breaker, right? And you're gonna do
Yes.
the high pot on this next week because that's the only medium voltage breaker we have in this class.
Okay.
You can, since this is one of the newer type of breakers, you can find the installation, operation, and maintenance manual for this breaker. This is what I downloaded online. If you want, I can share it with you. It's 72 pages. I never read the whole thing, and bless you. You did the DLRO on this breaker. Do you remember the test results for DLRO
Passed.
on this vacuum breaker?
Last week?
One of the legs to ground, I think was bad, I think.
Takes to ground,
I mean,
Face to ground.
and you said passed.
I think it was
Yeah.
on the vacuum one.
Yes, vacuum breaker. In this classroom, we have only one
Yeah,
medium
I don't
voltage
think
breaker.
that one passed.
Okay, what was the test results? Anyone remembers?
Yeah, for several of them.
Are you talking about the math?
Yeah,
I got the math
the
written.
fail.
It failed.
Yeah.
So the numbers
basic-
roughly.
Oh.
300
There was
amps, 300
there was
amps.
one- There was a
No,
hundred,
it's not amps. We are talking
no,
about
it's
the
25.
If I recall correctly, I believe it passed the Megger test, but it failed the duct.
Yeah,
Okay.
yeah, cause, for the DLRO, we got 25 microns for A, and then B, we got 220 microns, and the last one, we got 100.
220 and 100. Yes, Sean.
Most likely a bad vacuum bottle.
That vacuum was.
Yeah.
So, the person who pointed out to this section in this manual, and I know he went through the whole thing, and I guess that was the only student we've had throughout the years reading the entire thing was
Oh,
John
John.
Sandry, and he's working for RISA now. Yo, be a good reader. So what he
I'll read it. Yeah, send it.
showed me. Where did it go? Oh yeah. For primary circuit resistance check. So in NIRA MTS, any section that you go to, they tell you to refer to manufactured documents. In the absence of manufactured documents, apply 50% rule for doctor or DLR. Now, if you read here, it says for WCP breakers, you are supposed to close the breaker, pass at least 100 amps DC through the circuit breaker with a low resistance instrument or DLRO, measure resistance across the studs on the circuit breaker. The resistance should not exceed the values in this table. The breaker we have is 1200 amps. So for 1200 amps, your contact resistance is not supposed to go above 60 microohms. So they are not talking about the 50% rule. They are saying measure all three phases. As long as all of them are below 60 microohms, you're good. So that's what we are referring to, manufactured document. In the absence of manufactured document, go with 50% rule. But here we have it. So did you have any reading above 60 microohms?
Yeah.
So based on this criteria, it failed. So that's the proper way to test it. So that's for DLRO, but now again, we're gonna be focused on the control circuit. Here you see two diagrams. It's coming from the same manual. One of them is for DC control schematics, one of them for AC control schematics. Some of the breakers, they have DC control, some of them AC, some of them both. So, it differs. Now, assuming this circuit breaker is AC, this is the nameplate of the breaker. It's already on canvas, you can take a picture yourself, but this is the name. You have the type, and you have the rated maximum voltage. 15 kV is the maximum, but the operating voltage is 12 kV typically. 12.4, but 15 is the maximum rated voltage. The impulse voltage is momentarily for the lightning. It can tolerate up to 95 kV. Rated continuous current, 1200 amps, frequency 60 hertz. Rated short circuit current, up to 18 kiloamps. It can safely interrupt the circuit, but if your fault current is above 18 kiloamps, we don't know. It may work, it may not work, it may explode, we don't know. The manufacturer tested it up to 18 kiloamps. So that's what's guaranteed for. Let's see what else we have here. The K factor for the voltage 1.3, that's for asymmetrical, rated interrupting time 5 cycles. So maximum it takes 5 cycles to clear the fault. Close and latch current 62 kiloamps years. IB, I don't know what
That's
IB.
a serial
Your
number.
service number?
Serial number, no?
Serial number is on the first row. Wiring diagram, motor voltage. Okay, this is what we're gonna do tonight. The voltage. So here, it's telling you close current and voltage range and tripping, trip current, trip voltage, and the motor volt. So you see 3 voltages. Let's start with the first one. Motor volt. Motor volt means charging. How much voltage you're supposed to apply to charge the breaker. So instead of manually using the handle to charge the spring, we're gonna apply 120 volt. It doesn't matter. It both works on DC and AC. It doesn't matter DC or AC. Both works. 125 volts, and then connected to the right pin, the terminal numbers, and then the motor is gonna charge the spring. That's what I like to do, because I'm not as strong as Neil, so Neil can do it manually and electronically, but I like it electronically. Now, when you charge the spring, you wanna close it. What you did a couple of weeks ago, you press the button, right? But now, instead of doing it manually, we can apply the voltage to the right terminals between 104 to 127 volt AC, that's the range, and then it's gonna close. Your closing current is gonna be 6.6 amps. If you wanna trip the breaker, you can press the button manually, or you can apply 120 volt AC to the right terminals and trip the breaker. Now the question is, what terminals should we apply these voltages? We're gonna start with the first one, charging the motor. And that's gonna be the PDF you have in your hand. So let's zoom into this diagram, again assuming it's AC. Good news, everything is listed on the bottom, and if it's too small, my apologies, if you have difficulty reading that, you can open it on Canvas. So this PDF is already available on Canvas, and then you can zoom in. Good news, everything is listed here. So you have all the legends. These, you have the pin numbers, so it's numbered 1, 2, 4, 7, 6, 21, 24, 2, no, right here, 2, 24, 21, 20, 16, and here are the other terminals, 19, 18, 17, 15, 7, 8, 10, 3. So you have all these terminal numbers. So we have all these pins. We just need to understand which pins to apply the voltage. You have some coils. Coil is what you energize. You apply the voltage to the coil, and then it's gonna actuate one of these contacts. So by actuating this, by applying voltage to one of these coils, you're gonna change the status of one or multiple contacts. That's what it means. Now, CS is the control switch closing, CSC, CST is control switch for tripping. Y is anti-pump relay, SR is the spring release coil, closed coil, M is the spring charging motor. So this is what's charging the circuit breaker. SC is the shunt trip coil, PR is the protective relay, and these arrows or chevrons are for secondary disconnect. Again, everything on the secondary.
We're gonna be looking at the DC, right?
This is AC. So assuming it's AC. Now, for charging the relay, which coil should I pick and inject the voltage? Or charging the
Charging the spring,
So this spring or?
charging motor?
1 and 24.
1 and 24, perfect. So we just need to find pin number 1 and pin number 24, and then how many volts should I apply?
125.
Perfect, that's what we're gonna do tonight. We're gonna apply 125 volt AC to pin 1 and 24, we're gonna charge it. Next, we're gonna close it.
125 or 120?
We're gonna try it out. I mean, based on what we have, motor volt. Motor is for charging. So then,
Yeah, this is a long class.
I don't see that much of a difference between AC and DC between what we're gonna do tonight. So we can look at the DC, the first one on top of the page, because I see they are different. So 1 and 24.
Hey, just a quick question.
Uh-huh.
In the top right-hand corner on the thing, it says UV. I don't see a call out for that in the.
UV is under voltage, but let's see.
There's a circle of UV in the little box. There's a UV.
UV is under voltage, so under voltage coil. It means when the breaker is completely isolated from the circuit, that coil is gonna be energized and it's gonna trigger one of the contacts. A lot of breakers have the UV, under voltage. Under voltage means it's completely off, right? So it's for safety. We call it, in a general category, we call it some permissive contacts. So if you, in the absence of voltage, you cannot do anything. Now, the next one, we said the next one, we're gonna close the breaker. For closing,
For me, I said 4 and 21.
for closing, what coil we should target? This is our
4 and 21.
Jasmine said it. So SR, the spring release coil or closed coil. You're right, Jasmine. So SR and Miguel, you said
4 and 21.
421. I love 420. It should be 420, but
It's the day after, so.
yeah, it's the day after.
Just means extra,
Yeah.
extra, a little bit extra.
420, and then everyone takes a day off on 421. All right, so 421. How many volts we should apply?
It should be between 104 to 127 AC volts.
Beautiful. And the last action is gonna be tripping the breaker. For tripping the breaker,
It should
what
be
coil we should be looking at?
Yeah, I guess
ST1.
ST, that's right. So ST is the shunt trip coil. So ST, let me go to this.
It should be 6 and 19.
6 and 19. And how many volts?
120 AC volts.
120 AC volt. Any questions? That's exactly what we're gonna do, and I'm gonna walk you through that, but I need a volunteer to perform the charging, closing, tripping. Alright, so you two work together. Alright,
420 time?
4 and 21. Okay? 4 and
the day
21.
after.
Are we gonna bring it over here, or?
No, I think
If you can, but I'm sure you cannot, it's fine.